Well, hello, and welcome on behalf of Carnegie Mellon to the Corporate Startup Labs Forum. We're very excited to have you here. As Sean said, I'm kind of kicking off a block of data-related programming, and so I really would like to maybe just, this is a good opportunity to pivot a little bit and think about how it's all about the data. So why is it such a good thing that you're here in Pittsburgh and you're here at Carnegie Mellon for this? Well, here's what happens. What happens is you make smart aleck comments when you're giving a speech and you're talking about data science and you're like, please, if data science were a country, Pittsburgh would be the capital, hello. And someone captures it and they turn it into a meme and then it goes to the mayor's office and then it goes all over social media. And so this is, but I really do believe this. I think one of the nice things about being part of this kind of this sort of community in Pittsburgh and beyond is that you really get to take advantage of a lot of the academic and the innovation ecosystem that exists in this area. So at the dinner last night, some of us were having a conversation at the Oaklander about how, you know, this compared to like a Silicon Valley or compared to like a New York City or something like that or other VC heavy areas, what's nice about Pittsburgh is that we have all of those major players. We have this incredible innovation economy, but this is the kind of place where you can just like make a phone call. Do you know what I mean? And you can get connected to somebody really easily. So I'm really happy to see all of you here, those in person, of course, those online. And we're hoping that you stay connected to the Corporate Startup Lab as well as Carnegie Mellon in general, and that you're all taking the opportunity to learn from each other. Okay, so who am I? Right? Why does Sean get into all of those shenanigans with me? So I'm the head of the Department of Statistics and Data Science at Carnegie Mellon. And part of my portfolio is I do an awful lot of work with data science experiential learning. So think of that as like we build partnerships with industries. They could be for-profit, nonprofit, government agencies, startups with 6 people, Fortune 100 companies, you name it, we've worked with them. But we work on bringing real problems that are centered in data, AI, machine learning, et cetera, and we bring them to campus, we bring them into the classrooms, into faculty's research agenda, et cetera. I also do an awful lot of work on trying to determine what do we actually need to do when we're training people on data science, AI, ML related disciplines. So I do a lot of work with the national academies, trying to figure out what kind of training do we need in this discipline, particularly as disciplines evolve, things happen over time, then technology changes, et cetera. And then in my own personal life here, besides hanging out in Antarctica with the penguins, which I'm very happy to talk about at the reception, I do an awful lot of work on the science of data science. So I research how and why people do data science, how they analyze data, how they work on teams to analyze data, how we try to build data-centric solutions with teams. We do research on that, kind of using platforms and looking at their actions behind the scenes. And so we develop an awful lot of low-barrier data analysis training opportunities and platforms so that the entire world can level up on data skills and not just people who are getting degrees in AI or data science or ML. I'm a huge proponent of data belong to everybody. This data science belongs to everybody, particularly with kind of the change in economy that we're going through right now. If you are not leveling up your every single employee in your enterprise or building infrastructure so that you can do that, then you're going to be behind, right? So this is something to be thinking about doing on a day-to-day basis. Okay, so let's just kind of give a sense of some questions to ask when we're thinking about data. This is what my mother thinks I do for a living. Yeah, this is the world she thinks I live in, like I am swooping around all Matrix style, and I am Tony Starking things up in the air, and I am throwing open windows, and I am, shooting and having fights with robots. And I let her think this because this is really good for our relationship, right? But I always say, Mom, it's important to understand that I'm Trinity in this situation, right? I am the one floating up in the air. I am in control of the data. I am in control of the AI and the ML. This is not like I'm letting a robot do my job for me, right? Like I am making data-informed decisions. I am deciding what to do with all of these incredible technologies and tools that are available to us. People first, people center. All right, these are all tools that we're going to use. We're not going to get rid of the people. We're just going to kind of change their jobs and change how they interact with data. So why is it so important to make these kinds of points when we're thinking about our enterprises, thinking about building our companies? And the reason is that if you do things like just Google, learn more about machine learning, or like, I want to get a degree in AI, you see images like this. So it doesn't even matter if you can read it. Like, don't even worry about it. This is an image that is full of packages and frameworks and programming languages and things that are associated with machine learning and AI. This is cool. I mean, let's be clear. This is fantastic that all of these things exist. That's wonderful. I am a fan. The flip side of that coin is this is incredibly intimidating to anybody who is not have that background. Right? If people want to get connected to data, connected to using it as part of their personal lives, as part of their company culture, when you show them things like, look at all the things you need to do and stuff you have to learn, they opt out. They walk away. It's a big culture change management problem. We see it all the time. All right? So we need to be rethinking that this is actually just one piece of how we use data to solve a problem. This is honestly one of the smallest pieces of how we use data to solve a problem. So what I'd like to kind of get you to start thinking about is how it's all really actually about the data. So I love this cartoon because it's like, we've got this elephant, and everyone's like, let's talk deep learning. Let's talk about AI. Let's talk about how this is big data. Let's clean the data. And then this gentleman's like, has anybody actually fed the elephant? Right? Like, are we even thinking about what we're putting into this system? Or are we mostly thinking about the tools and the technology and the packages we're going to run, but not thinking about actually taking care of it? Right? What kind of information and data do we want to be putting into a system, an AI system, a machine learning system, in order to get the most value out of it, right? In order to leverage it. The other thing we hear a lot about that I want to make sure people kind of spend a second thinking about is, so this is from XKCD. So this idea of like, well, this is just how you do it. So what you do is like, there's some data, and then you throw some stuff at it, and then if you don't like the results, you just kind of do it again, maybe, or you like shuffle the data a little bit, or you like find some new package, and that scares the hell out of me. Just absolutely terrifies me, although this cartoon is hysterical. I'll tell you why. We are seeing more and more, and part of this is because packages, frameworks, programming languages, it's actually becoming much easier to use them. So this was good, right? This is exciting that we are making these things available to everyone. You can bring in AI into your company. You can bring in a machine learning algorithm into your company. Lots of people can click buttons and make them run, but people don't understand very often what's being used. What's the advantages? What are the disadvantages? What do the results mean? And the kinds of things we're seeing more and more of, people using these packages, seeing results they don't understand or they don't like, and then instead of trying to understand it, saying, I'm going to go find another package, right? Like just trying to find tools, like just because you know how to get something to run doesn't mean you sort of understand what it's doing. And we're really seeing a lot of companies push back on this idea of just run the models and let the models figure it out, because they're realizing in some ways just using tools and no one's understanding what they're doing is we've swung too far on that pendulum. So we need to kind of come back a little bit and think a little bit about data. So if I'm thinking about like AI and machine learning and data science, one thing to keep in mind is, and I'm going to show like a larger picture in a second, is that machine learning is a subset of tools, it's a subset of algorithms inside AI. So you can use ML inside AI, which is like an artificial program that can like reason, think, adapt, that sort of thing. But both of those things are used as part of data science. Solving a real problem with data, AI and ML are, again, I said it earlier, a small piece of that entire process, all right? So on the picture on the left is from BrainCube, and the picture on the right is from a very famous statistician so it's in my field. And in that case, they're saying, well, data science actually just kind of overlaps. You can use AI and machine learning and deep learning inside a data science problem. You actually don't have to. You can use all kinds of different things. The umbrella of what people call AI and ML is getting larger and larger. Sean and I talk about this a lot. We see people use these terms quite often, and then I think what Sean says, or he may have said it earlier this morning, is oftentimes people are running a linear regression on a data set, right? But they're calling it AI, and we're like, let's get down to fundamentals. What are you actually really doing here? So the idea is I want to get you not to just think about how you can use AI and ML in your own startups, in your own companies, your own product lines, et cetera, as part of innovation. But I'd really love you to come back and think about the whole picture, the whole big picture, and about how it's really about the data. We understand how to do the models part really well. We've got the tools, we've got the frameworks, we've got the technology, but most of the action is going to happen around the other parts. Is it okay to grab a mic here? Yeah. Okay. We're going to go a little rogue. Are we going rogue? Yeah, we're going rogue. Okay, so to my friends on that side, I'm going to try to call it out as I'm talking over here. So I don't have a relationship to disclose necessarily with Microsoft Azure. I just like this picture. But if you look up at the top of this, what we're going to do with data, we're going to start with the business understanding. I can't tell you how many groups do not spend enough time here. You should be talking about data and how you want to solve problems and not actually looking at data. Like, don't let people have any data. This sounds bizarre, but the first thing people do when you hand them data is code town, yeah? And they forget to actually think. They get super into the programming. They're like, I want to start running models. And I'm like, you don't even know what you have. And they're like, but the models, so you really want to spend a lot of time on the business understanding. When we come down to the right, to data acquisition and understanding, that's the more technical data engineering side of it. That's building pipelines, that's trying to get data, put it into the right place, thinking about storage, infrastructure, et cetera. And then we move over to the left toward modeling. So maybe I have an outcome I'm interested in. Maybe I just want to think about looking for structure in data, try to look for patterns, behavioral differences, things like that. But there I'm going to be thinking about, you're going to hear words, right? I'm sort of designing what features I want to put in. I'm thinking about how well my model is doing, evaluating it, looking for overfitting, et cetera. And then at the end, we come down to deployment and customer acceptance. In that case, we are actually trying to see, of all this fancy technical stuff we did, does it actually work? Do our customers and stakeholders accept it? Will they adopt it? Do they know how to use it? So in my experience, the years of working with lots of external partners, most people and most students, to be honest, focus on the middle ones, the data acquisition and the modeling. They gain lots of technical skills in these courses. We hire them into companies. Everyone's focused on the data and getting the data and building the models. And that's great. Those are hard things. We should be putting energy there. But we're ignoring, are we even answering the business question that we want to answer? And how do we actually get this to be used? Because when it boils down to it, really comes down to kind of communication. And that's where we fall apart quite a bit. So when we think about business understanding, you're asking yourselves the questions, business case question, what's the value to my stakeholders? I need some domain expertise here. Data acquisition and understanding, what data do we need? Where is it? Storage, et cetera. Modeling, identifying outcomes, variables. And in deployment, I'm trying to summarize, display model results. Explain the impact and relevance to stakeholders. And thinking about what do we actually store? What do we keep? Explaining the impact and relevance to stakeholders is something that everyone needs, myself included. Every person on the planet needs more experience with this, I'll say. I can't tell you how many students we see who start explaining really complicated models to a CEO, and they start talking about all the packages and things they're learning, and they're like, and then I did my scikit-learn random forest, and I tuned my parameters, and I t-sneed it up, and it was amazing. And the person's like, what the hell are you talking about, right? There's no sense of, how do I take all of this technical work and really distill it down into communication? How do I bring this into actionable insights? That's where we're falling down a little bit, and we really need to push for that more. So the next two slides are just, I wanted to highlight, I'm happy to talk about this. In the interest of time, I'm just going to say I'll talk about this with you at the reception. But there are 6 different roles, of the data roles at any enterprise, and we have technical ones at the top, data engineer, scientist, analyst. But by far and away, the biggest roles are data users, the domain experts, the decision makers. For every company I've ever worked with, the number of technical data people is like this, and everybody else is like this. Yeah? So if you do not thinking about, sorry, I took the microphone away, or, to protect, my arms are wide for our virtual friends. So if you're not thinking about how to bring data literacy to your entire company, you have a lot of missed opportunities here. All right, so coming back to our workflows, just thinking about some different examples. So I wanted to give you kind of one example to think about, and I actually am going to call on the crowd a little bit here, so get ready. We think about modeling pandemics, right? We're all sort of hopefully on the other side of this, but epidemiological forecasting is crucial for public health officials, pharmaceutical companies, social services, et cetera. We need to manage resource allocation. We understand manufacturing needs, work with logistics companies, do public awareness. And that requires us to bring experts together across all kinds of disciplines, right? We have to engage with the public. We're going to get all kinds of data from different sources. We need to build visualizations, create models that we can interpret, and communicate these results as actionable recommendations. This is literally a perfect data science problem. Every single aspect of what we need to do with data to solve a real problem, this is a great example. So a group here at Carnegie Mellon called the Delphi Group. This is, it's in our department, statistics, data science, machine learning, computational biology, human-computer interaction. There are loads of other departments around the country now who are involved, as well as several companies. It is part of a national center of excellence here. And where our ability to start to improve forecasting of these kinds of epidemics came from is using different kinds of data sources. So we started with flu, actually. We did a national competition. We participated in predicting flu rates. It's called nowcasting. What are flu rates right now versus what are flu rates going to be, say, in a month? And we won 4 years in a row. Boom. All right. Just, throw that out there. But one of the reasons why we did so well is because we incorporated non-traditional data sources. So instead of just getting things from hospitals, the CDC, all kinds of the healthcare related data, we did things like depend on the wisdom of the crowds. How many people are Googling things about flu? Flu symptoms, right? I have flu, how to get over flu, things like that. We looked at article access. How many people are looking up things on Wikipedia or on the CDC about flu? Twitter flu-related tweets. And you can imagine with, Twitter, everyone just have a moment where you think about what data is like on Twitter. But people tweet about the flu. Yeah, they tweet about everything, right? It's a lot. So there's a whole, set of data problems here. But thinking about it, people are offering data in unusual or different ways that actually help us proxy and understand what's happening from the public health perspective. So a couple years ago, of course, when COVID hit, the CDC asked us to switch to COVID-19. And so the types of things that we were able to get with our partners, both our corporate partners and our academic partners and our government partners, we got doctor visits, telemedicine and in person. We ran the largest, it's still running, you may have gotten this if you're on Facebook. We're running the largest survey that has ever been run outside of the census on Facebook about pandemics and about COVID-19. So I think, we get tens of thousands of responses every single day about symptoms, what's happening in your neighborhood, what's going on, et cetera. So we get symptoms, we get self-reported things about mask wearing, we get vaccine hesitancy, we look at Google search trends. So a lot of these, if you notice those middle ones I just said, those are not captured by the traditional healthcare systems, not even remotely. Right? We are getting them. We are getting other data sources. And it helps us when we supplement those with the traditional sources. That's when we get improved forecasting. That's when we do really well. So can you guys think of any other data sources that might be useful? So non-traditional data sources. Let's just throw it to the audience here for a second. School absences, yeah, thank you. If we got school absences, we might be able to know something, right, about what's happening in the local community. Yeah, over-the-counter medicine purchases, so if you can get pharma data somehow, but specifically with respect to the OTC stuff, right, versus the prescription things, that helps us out. Yeah, what else?
Sick leave data from apps that do time cards and time cards.
Yeah, that's great. Oh, that's good. Okay, that's good, yeah. Note. All right, so sick leave data from time cards from the apps. I hadn't thought about the apps. Yeah, okay, so he gets a bonus. All right. So, no, but this kind of stuff where you think this is just normal data that people are collecting, right, all the time. But you can pull that into the system, right? And it's all about the value that it adds that helps us capture things that we wouldn't have understood, right? That we wouldn't have understood otherwise. So, and what you end up discovering is you learn all kinds of different quirks in the system. So, for example, we had a group of undergrads working in a particular area of the United States, and they came in one day for a meeting, and they were like, "We got it, we solved COVID." And all of us were like, "Do tell, because that would be great." You know, like, what's going on? And they're like, "Everybody gets COVID on Monday. We just close everything down on Monday and it's good." And I was like, okay, no, wait, what? But the data really did show it. They showed us their work, they showed us the models, the code, and we were like, Monday, right? Like, what's going on here? And it turned out when we went to go talk to the domain experts for the public healthcare systems in that particular area of the country, that there were these resource constraints that, of course, none of us knew about. And their reporting systems didn't work very well. There was an area where they weren't able to report things except every like 4 or 5 days. So it really did look like these big spikes were coming in and everyone needed to stay home on Monday. But it's that domain expertise and that extra knowledge that we needed to pull in. And when we pulled that into the models, we pulled all that data in about the reporting systems, et cetera, then of course we were able to do much better and we were able to correct those models and whatnot. But it took talking to domain experts, right? It took talking to, you don't just want to rely on the apps, although we will. Like, you don't just want to rely on the automatic feeds. You really need to be pulling in the domain experts. You need to be talking to people and finding out the things that the regular, like, electronic data is not going to be able to show you. And while it was such a blow to our students that Monday wasn't the answer, it was an incredibly good learning experience. And actually, we improved the models for that area of the country quite a bit throughout that process. And that's actually the biggest issue. Again, we understand how to do the models. We understand all that. We got it. We can do the machine learning, we can do the models, it's fine. It's all the rest of it, right, that we need to spend a lot of time on and working through that with people, domain experts, what data sets, which ones are valuable, which ones are not, which ones are expensive to get and don't offer much value. That's an incredibly important thing to discover so you don't spend your time, over there, et cetera. So if you just Google COVIDcast, you'll see all kinds of public dashboards that we had to make. And we did an awful lot of communicating with the public in terms of writing blog posts, going on NPR, going to town halls, which was quite an experience, and doing all sorts of things that was very public facing, because it turned out, that the communication was really the key thing, okay? Again, it doesn't matter like how good my model is, right? And like how great the AI is, because this is what happens to me. Do you know what I mean? Like, I'm like, and here's your dashboard. And people are like, and I don't believe any of it. And you're like, no, right? So it can either be, we've looked at all the data, and because we didn't have enough of a conversation ahead of time about what data sets, we might discover that things are useful. The other problem is that we just get overwhelmed. We're just completely overwhelmed, right, by all of the data and all the information there. So thinking very carefully about what data is valuable, how to communicate that to the public, to your customers, to your stakeholders, et cetera. I mean, you guys want to bring data journalists on your team. This is something that's becoming more and more of a new hire, is to bring in specifically communication experts on data. like new master's programs are being developed in this area, new courses, faculty, people are graduating with degrees in this because it is so crucial. So I would highly recommend reaching out to that. So to try to keep us a little bit back on schedule, I'll just mention briefly that with respect to how we communicate with everyone and try to learn about what they think about data and how they use data, we use something called the Integrated Statistics Learning Environment, or ISLE, which is it's a browser-based platform that allows people to interact with data and models, collaborate, think like Google Sheets or Google Docs, but for data analysis. But we track everything on the back end, and that allows us to do research on what's the optimal way to analyze a data set as part of a team, or what's the optimal way to create a presentation. It also allows us to do professional development, educational workforce training. So some of the partners that we work with develop programs to help all of their employees learn something about data, learn something about statistics, learn something about machine learning, so that you can talk about it in your company. We don't necessarily need to turn people into experts, but we do need to facilitate conversations. Everybody should be able to have a conversation about the data that any company is using or working with, regardless of what your role is. So it's really about connecting people about the data that are being used to solve their problem, not necessarily that you're trying to turn everybody into data scientists. So happy to talk about that. Another thing that's coming online at Carnegie Mellon next year is there'll be a Foundations of Data Science online certificate that might be a really good fit for some of you and some of your employees, that you could work at your own pace and learn a little bit about data and data science, et cetera. All right, so I'll leave you with great power comes great responsibility. In the age of big data, we're always hearing about the push to automate decisions using data science and AI. We talked about it in the beginning. It's not so much that we're going to let robots take over. People are in charge of this. You are all Trinity in the Matrix, right? You are in charge of your own data, your own use of AI, your own use of ML, et cetera. Humans are going to be necessary. We're going to put them in the leadership roles. So when we think about more data, it doesn't mean you have better data. Spend quite a lot of time thinking about what the right data sets are and how to get them. Don't just try to dump, now that it's so easy to grab data, people just dump it into storage things and then go here. No. Like, stop and think about what you're actually collecting and why you're collecting it. And the last thing that I want to comment on is that when you use data from the past, you're only ever going to predict the exact same behavior from the past. If you are trying to innovate, if you are trying to change your practices, you're going to need to incorporate historical data with your goals when you build this system. Otherwise, you're just going to keep predicting, oh yeah, hire this person. Oh yeah, go to this market. Because anything you build with AI ML is going to be using the data from what you've done in the past. So if you really are forward-looking, make sure that you're putting those new principles, those new goals, et cetera, into the system that you're trying to design. Everything is about the data. Lastly, when you are thinking about hiring, this is just my personal request. I'm ending on a personal crest. Please be very thoughtful or take into consideration that while we often live in a world where we're surrounded by apps and tools and technology, that there are millions of people in this country and billions of people in the world who have not had the same access to that kind of tools and technology. And that does not mean they are not talented individuals who could be leveled up and moved into these data-centric roles. It just means they haven't had the chance yet. So be really cautious about over-relying on, well, you have like an AI degree from this place, et cetera. We're seeing a lot of barriers being put into place that certain populations are not getting opportunities to move into this space simply because their backgrounds are different, et cetera. So I'd like to request that everyone think about how data science, AI, and ML really belong to everybody, and that we can use it to level up everybody in terms of opportunities, innovation, and the corporate world in general. So thank you so much. Really appreciate your time. And again, welcome to Carnegie Mellon. Thanks.